Mr. Minnick here, helping my Visual Basic students with the board game project. Make sure you download the starting demo version of the project. Download it and unzip it, extract it, whatever you have to do, to a point where you can then come in and see the interface that I'm giving you, as well as the code window that I'm giving you. In the code window, shrink all of your private sub and subs, all of your methods, so that it looks like this. And let's discuss it. Well, in this program, after executing it to see what it does, when a person clicks this graphic here for a dice tumbler cup, it rolls the dice and shows the appropriate picture and moves the player. Well, it's player one's turn, or it was player one's turn. He rolled a 5, and it moved across this creative board game layout from square 0, the start, to 1, to 2, to 3, to 4, to 5. Good, he did land in 5, that worked. Okay, so it works a little bit. Player 2 is not working, and there's a lot of other things that, there are a lot of other things that you have to finish. So let's start examining the code. Well, we have 3 module level variables. Let's put a nice little comment in there. These are module variables that are being declared above all of the methods. So the variable mPlayer1 square can be used in any of these methods. Its scope is quite wide. It can be used anywhere in the program. And it has the prefix m because that's good style when naming a variable whose purpose is to be a module level variable. And I have little comments over here to the right that explain that. Let's bring those back into play here, so that you can see that in the screen. And everything's good. We're keeping track of where the player 1 is, what numbered position on the game board that player is, and we're keeping track of player 2, and we're also keeping track of whose turn it is by storing the number 1 if it's player 1's turn, or storing the number 2 there if it's player 2's turn. Maybe you want to add here in parentheses that this is always going to be a 1 or a 2. Okay, so we have 3 module level variables. Moving on, the program, when it loads, it does this randomize, which you can read about in the lecture notes. That makes the program interesting so that every time that the program runs, different random numbers pop up. Well, I don't want that behavior right now. During the testing of a program and the debugging of it, I don't want random behavior. I want this program to be consistent. Every time it runs, let's see what happens. Yes, I get a 5. Every single time I run the program, as you see, and click the dice cup, it gets a 5. That's nice for now. When I hand this program in or sell it as an app for 99 cents, I certainly would want to bring that statement randomize in to my form load method so that the dice tumbler gets shaken up and I get different dice rolls every time I load and run the program. Okay, so for now we're disabling that, and let's move on to the next thing that happens when this program runs. Form paint. The program paints the screen. The graphics window suddenly has happy little rectangles drawn on it. Some words, also known as strings, like this +3 ends up showing up in the word back. So I run the program just to see that yes, this program does have 7 squares. 0, 1, 2, 3, 4, 5, 6. That's a total of 7, by the way. Count with me. 0, 1, 2, 3, 4, 5, 6. No, 1, 2, 3, 4, 5, 6, 7. But they're numbered 0, 1, 2, 3, 4, 5, 6. Okay, so that's my unique arrangement. You can, of course, change these draw rectangle parameters to whatever numbers you need them to be. You should look up how the draw rectangle works. We studied that months ago. It's in the lecture notes. You can remember what appends.black does. And with a fill rectangle, of course, you use a brush. Well, in this assignment, you need 3 or more special squares. In this demo, I have 2 special squares. And the one, as you see, moves the player ahead 3, and the other one is meant to send him back to the start of the maze. And overall, you need at least 15 board game squares. So add more draw rectangles if when you get to it. Okay, so that much of the program is done, but you'll need to change that around to meet your needs. Now let's really get into the inner working of this program. When somebody clicks the dice cup, when somebody clicks this picture box named Pick Dice Cup, see the name of it right here? It's that's how I know what it is. It's a picture box, so it has the prefix MIC, PIC, and it's named Pick Dice Club. So when somebody double clicks that, or single clicks it, their code executes. That's in the Pick Dice Cup click method. Well, here I gave you the idea of having a local variable, dice roll. And I didn't put a little comment. Oh, I did. I put a little comment here that says it's the dice roll. Now, this is 1 to 6 in this program. But you could change this program so that using your random number formula, you could generate random numbers between 1 and 7, or 1 and 15, or any low number to high number. And what else is happening here? This line of code calls the function getRandom. So getRandom is a function, but it's not built into Visual Basic. Look at what we have down below here. We have a function, something called a function here called getRandom. It's a little different from a sub. Instead of private sub, it's private function. And we haven't studied functions yet that much in this school year, but here's an introduction to them. If you look in the body of this function, there's one line of code, and the word return means that a random number between high and low is sent back up to wherever getRandom was called. Oh, look, see this 1 and 6? They match up with int low and int high. And this is a little old-fashioned. I don't really do this anymore, so I'm going to change int low to just plain low. And the word int high, I'm not going to use the prefix int, which used to mean integer. Some people still use that technique. I don't. So I'm just changing those spellings there to low and high without the int prefix. And trust me, this getRandom function works. Because of this formula, it always returns a number between 1 and 6. Okay, so you can pretty much tuck that away and have peace of mind knowing that that always works. So I'm going to do that, tuck it away there, and scroll back up, and trust that this always ends up being a number between 1 and 6, and that return value, that number, gets plugged into dice roll. So this 0 is not there anymore. That 0 in dice roll is now overwritten with some number between 1 and 6. If the number is 1, and let's hardwire the program to make it a 1, put a 1 there and temporarily disable the getRandom part. Run the program and notice that every time you run the program now, it's always a 1. This blue player 1 always moves 1 square. Every single time I run the program, it has to be that way. Because I, the programmer, programmed it that way. I control this program. I control the code. Sorry about that. I'm closing up things there that you don't need to see. Okay. So that's that. So with this set as 1, let's make sure we understand what's happening in this if, else, if, else, if, else, if. Is dice roll, Nathan, equal to 1 under the scenario that I've currently explained?
Yes.
True. So because that's true, this line of code executes, which means that we're changing the image property of this picture box right here that was empty. It's called Pick Dice. Don't confuse it with Pick Dice Cup. That's Pick Dice Cup, and that just happens to be right above Pick Dice. So Pick Dice's image property, which was nothing, none, it's being changed to whatever this right-hand side is. Well, this is just a fancy way of saying whatever graphic is named Dice 1 that's found in the resources of this project, which is, you see over here, resources. Okay, if you don't see that, you have to know to click that triangle, then go in resources and click that, and dice 1 should be in here, and it is. The 3-letter prefix, suffix, extension, I meant to say, .gif, .jpeg, that does not get typed over here. And board game is the name of my project officially. So even though it says lowercase here, just trust me, it's actually board game with capital B and G. Well, if you had 7 dice, you could copy paste this else if, put it inside here, but you would have to go on the internet and find or draw by hand a dice 7 graphic, because I don't have a dice 7 graphic in here. And you would have to add it to your project as a resource. Here's how you do that. Any graphic that you want to pop up in this sort of way that I'm teaching you here in Visual Basic using this notation, you right-click on Resources, you go to Add, and you add a new item. You browse your hard drive. No, not a new item. I'm sorry. You add an existing item. Add existing item. Then you browse to, say, your My Pictures folder, and you add something that you might have drew from scratch or whatever. Now you do have to be sure to change the little setting here to all files. Now I get to see all the graphics files that are on my computer. It's kind of silly to put penguins that I got for free on this computer into this project, but I'm going to do it anyway. Oh, before you ever add a resource in this way, make sure there are no spaces in the file name. And I recommend to just keep everything lowercase. So I'm going to rename that. The penguins, I'm going to rename it as a lowercase penguins. Oh, my operating system is forcing me to keep it a capital. So just, if you can, change it to lowercase. If not, it's not that big of a deal. And now I'm going to click Add. And over here now, I should have penguins. Oh, isn't that cute? And I can come down here, and instead of dice 1, I could train my project to show penguins. See, penguins, even though it's a JPEG and not a GIF, it'll still work. And when I run the program and roll a 1, okay, it's not working here. Squiggly underlining. Let me check out that error real quickly. Now, I just added this resource by right-clicking over here, but let's go check to see if it's actually in the right folder. I'm going to right-click on Resources again, and this time instead of going to Add, I'm going to go to Open Folder in Windows Explorer. So what I just did was I'm opening my resources folder that's part of my project. You know how in the old days we used to go to board game and we double-clicked and went to bin, debug, and that's where we put sound audio files? Well, instead of going to bin, debug, we go into bin, resources. Or not bin, but before you go into bin, you go to resources. That's where you would put your picture. Well, I see they did that. It did get added in there, so it should not be squiggly underlining right now. I'm going to look at my error message, which I don't have an error message. Again, holding my mouse over this, apparently it thinks that penguins is not part of this project. Okay, Mr. Minnick doesn't know the answer to this. I'm just going to fast forward here and pretend that this never happened. Let's put this back to dice 1. I'm going to blame it on the network, because you know teachers can do that. Students can't, but teachers can. Okay, well anyway, when the dice does roll a 1, because I made it equal to a 1, trust me, this picture of dice 1 shows up in the picture box Pick Dice. Let's test rolling a 2 to make sure that dice 2 graphic shows up. So I change that 1 to a 2, I run the program, I click my dice cup, and it works. So right now the graphics do work. All 6 graphics for all dice rolls do work. Let's put this back to a 1 and examine what happens next. If player turn 1, we're adding dice roll plus equals to player 1's square. Oh, think about it. When you run this program, player 1 starts right here at 0. If you roll a 1, his position is now 0 plus 1. In other words, 1. And that is what square number he should be on. It is working. But does that actually move this blue graphic? No. This if-else-if statement does move the player in his mind. It tells him where his square should be by storing the right number in this variable player 1 square. And it also is toggling the variable player turn, so it's now player 2's turn next. Now we have to be fair. When it's player 2's turn, player 2 has to give up the turn to player 1. So this 2 and this 1 are important, just like this 1 and this 2. Shh. There have been, I've already done a lot of work on this assignment, but I want you all to understand it so that you can grow from this and maybe have a 3-player version. That could be extra credit, let's say. Or like a Monopoly where you can have like 5 people all playing at once. Okay, and of course it's always nice to tell the people whose turn it is, so that's just a little label there that I tell them whose turn it is. Okay, so this if-else-if statement updates the player game board position and toggles the player's turn. But it doesn't move the graphic. It just stores the right number in these 2 player square variables. The line of code right here is where we update the graphics. This is what makes the blue player move. This is a reusable method that when I created it, I called it update player positions. Let's scroll down and look to see what it does inside of it. Right here, click this little plus symbol, and let's look at the private sub update player positions. This is one big long if-else-if-else-if-else-if statement. This is where you have a lot of work to do over the next couple days. It works for me and my board layout, but you all have different arrangements of your board, plus you have 15 or more squares, and I only had 6 or 7. Let's check my board squares to understand why they work. Think about it. If player 1, right here, player 1, is on square 0, his left edge is at 35 and his top edge is at 55. If I had labeled graph paper, you would see and confirm that the top left corner of this little blue is the point 35, 55, XY. Let's ignore the red player right now, player 2. If the player is on square 1, which is really the second square here, the position right here of the top left corner is, well, Blanchet, you can tell me, because you can see the screen right now. Tell me where this blue guy goes when I roll a 1. Where will the blue guy go exactly? Give me the XY location. It's right here on the screen. Player 1, where does he move exactly when his square is position 1? Yes, folks at home listening to this video, he did correctly say 65, 85. Driven? If he rolled a 2, where would he land to be in the upper left corner of this green square?
He would land at 95, 150.
Excellent. X equals 95, also known as left edge. Y equals top edge 115. But because that's a special square, After telling the guy that he landed on the lottery winner, yay, congratulations, you move forward 3 squares. So I instantly add 3 plus equals. So I add 3 to his variable that keeps track of where he is. So he's no longer on 2. He has 3 added to that for a grand total of 5. And I probably should have put a note there that says, oh, I can't type right now because I'm running the program, but I should have said something like moving the player 3 squares ahead. Because that apparently 155, 145, Brian, what square number would that land my blue player in? Right here, not. He was at 2, correct, 5. And he adds 3 to that. This apparently is the coordinate. These are the coordinates for square 5, which Elena knows is not this one here. Even though she knows that when she counts 1, 2, 3, 4, 5, that is not square 5. Because we have to start at 0. 0, 1, 2, 3, 4, 5. That's where he belongs. Because I told you all the other night for homework to number your squares starting at 0. This helpful code only works if you start at 0. You're on your own if you started at 1 as a rebel. Okay, are there questions here in 2014-15 on the basic idea of you going in and changing these numbers tonight for homework or tomorrow in class so that your first 6 board squares work to match your graph paper, so that the logic of the code matches your interface? Then what you're going to find yourself doing is coming down here to say player square equals 5. Copy paste this else if and put it in here to where you can then add up to the 15 squares that you have to have for full credit. But stay away from this last else if. That's the winner. That's where you roll something that lands you greater, equal to, or above square 15 or so. That's where you won the game because you were the first player to get there. Don't mess with that one. You will have to change this 6 to some bigger number. How many people have more than 20 squares? Wow, let it be known for the record, there's a Dribbin, no, not a Dribbin. Oh. There's a Blanchet, there's a Wong, and there's a Goldberg. Now, keep your hands up. How many people have more than 30 squares? Oh, they're out. Wong, you are at least the person who bit off more than you can probably chew, a brave person. Let's see if he follows through with this next week. Part 2 coming later. Good luck with this stage of adding else ifs. And coming up here in your this line of code before the bell rings, change this to whatever number you need, like 12, whatever square number you need to test. Test it with player 1 only. We'll handle player 2 in part 2 of this video.